Hello, ladies and gentlemen. Today we're going to work on exponential growth and decay again for day 2. So let's take a look at this warm-up. Can you find these mistakes? So take a look at these first 2 questions. See if you can find the mistakes. Pause the video right here and then come back and you can hear the explanations. The mistake on the first question is that this right here can never go below that x-axis. It gets closer and closer and closer, but it never goes across the x-axis. Okay? Question number 2, the mistake, it might be a little hard to find because everything looks pretty good. They put in all the values in the correct spaces or places, okay? And then when they're calculating this, all of these are still good. But what happened here, okay, is that they took 9.955 and they didn't raise it to the 10th power. They took 0.955 and they multiplied it by 10. And that's how you get 9.55, which is incorrect. What you should have there is actually equal to 0.631. So that's what should go in there, not that. And so then of course it changes your answer. All right, well, let's see if you can pick out the mistakes on these 2 questions. So again, pause the video and see if you can pick out the mistakes and then start the video again. On this question, what they did is they took the percent, 3% right here, and they put it in as 3, okay? And it's not 3% like that. It's 3% means 3 over 100, 3 out of 100. So this should be 0.03, and that's what should go in right there. So that, of course, changes your answers as well. In the second question, what happened here is all of these look good, okay? They have all of these values correct. And they started plugging them in, but what they did is they have a plus right here, and it says it's decreasing. And so decreasing is not going to be a plus, it's going to be 1 minus 0.016. And then, of course, that's going to change that answer right there. So those are just some mistakes to be aware of and pay attention to as you're calculating these problems. So remember, exponential growth, okay, is 1 plus your rate of change. So a times 1 plus r raised to the t power, okay? And that 1 plus r raised to the t power, remember this part right here can also be just put in as one value b. Well, the first thing we're going to look at today is compound interest, okay? And in compound interest, okay, you've seen these equations before because you did some evaluating of them. But we're going to actually write the equations now. And so this is the equation right here for compound interest. A equals P times 1 plus R divided by N raised to the NT power. And so here, this is a good time for you to pause the video, write down this formula, and then write down what all of these letters mean, okay? A is the final amount or final balance, just like our Y was up here, okay? So that kind of stays the same. Now we're just changing the letter, but the number outside the parenthesis right here is still the original, okay? It was called letter A in general, but now we're calling it P for principal because when we talk about money, that's a banking term, okay? Principal, it's the principal or the amount, the original amount. The rate, okay, is the same, but it's just that the rate has to be divided by the number of times the interest is compounded. So this N right here and this N right here are the number of times that interest is compounded per year. And then T is the time again, okay? And usually T is time in years. So you have to think about what about compounding interest, okay? Well, it actually grows much faster when it's compounded. And so you have to know what are your N values, okay? So if it says that it's compounded annually, that would mean once per year. So then n equals 1, okay? If it's quarterly, think about a quarter. There's 4 quarters in a dollar, 4 quarters in a football game. So now our n is 4. So you would put a 4 in for n. If we talk about monthly, well, how many months are in a year? Well, 12. So n would be 12. Weekly, hopefully you know how many weeks are in a year. But if not, there are 52 weeks in a year. So n is 52. Daily, how many days are in a year? Hopefully, again, you know these things from previous knowledge. And there's also semi-annually. And semi-annually would be just twice a year. So those are the values you're going to need to put in for n. All right, so let's try a couple examples. And let's see if we can get these things in correctly. And remember, plugging these things in is one thing. Making sure we simplify it correctly is another. So it says, if $15,000 is invested at a rate of 4.8% compounded monthly, find the balance after 2 years. So start by just reading it once. Okay, now start plugging in the values. Okay, this is what's invested, 15,000. So that's going to go right here. That's our original amount that's invested. Okay, then we have 1 plus our rate. It has a rate of 4.8% right here. So remember, that has to change to a decimal, which means you're going to move the decimal point over 2 places, and this is going to be 0.048, or take 4.8 and divide it by 100. So now I have 0.048 is my rate, divided by the number of times it's compounded. It's compounded monthly here. So that's 12 times per year. So I put in a 12 right there. Then I raise it to the n, which is 12, times the time power. And the time here is 2. So that's what I need to type in. If I'm going to type this in my calculator exactly like you see it in one step, remember you are going to need a second parenthesis around there. Otherwise, what you can do is you can get a decimal for 0.048 and you can put it in as 1 plus 0.8. Oops, I did not divide that. 0.048 divided by 12 is equal to 0.004. Okay, so you could put it in like that way as well. Or you could just add those together. And that's where that B came from. All right, so now, again, calculate all that out. I'd pause the video right here and take a look and see if you can get the correct answer. Hopefully you calculated on your calculator correctly. $16,508.22. We always round money to the nearest hundredth. All right, let's take a look at one more with compound interest. Now it says $1,200 is invested at a rate of 2%. Compounded weekly, find the balance after 10 years. So A equals the original amount times 1 plus my rate of 2%, so that's 0.02. Again, here's your decimal point right here. Move it 2 places. And then I divide by weekly, which is 52 times a year, and raise that to the NT, so 52 times 10. And again, make sure you're putting this in parentheses right here as well, or just multiply that out, which would be in this case 520. So take a minute, pause the video right now, see if you can get the correct answer. And if you get the correct answer and you've entered it into your calculator correctly, you should get $1,465.63. All right, now we're going to look at exponential decay. And this is another special case of, we have another special case of exponential decay called half-life. Half-life is the time it takes for 1/2 of the substance to decay. So if you started with like 100 grams of something and it was cut in half, it'd be at 50. And if it was cut in half again, it'd be at 25, etc. So that's what we're talking about half-life. It's going to decay and cut in half, okay? So here, okay, our formula looks like this. Let's see if I can get it a little different color here. Here is our formula for half-life. So here again, pause the video, write down the formula and what these letters mean. So in this, again, A is our final amount, just like it was for Y and just like it was for compound interest. And P is still our original amount, okay? But T, this is the tricky part, okay? This T, oh, and we don't need 1 minus the rate because our rate is 50%. So if we take our rate and put it in as 1 minus 0.5, that equals 0.5. So that's why we don't need to write that in all the time. That's going to always stay the same because the rate that it's decaying is always 50%. So this part right here is always going to be 0.5 right in here. So we don't need that 1 minus. So let's keep going on this question and talk about T. So T, for the time, what we're going to put in is the time period divided by the half-life time. So what that means is if it cuts in half every 10 days and you want to know what the value is or how much is left after 100 days, that means it's cut in half 10 times. So this part right here is tricky, okay? So write that down for now, okay? And then when we do these two examples, I think it'll make more sense. So, all right, it says the half-life of bismuth 214 is approximately 20 minutes. Find the amount of bismuth 214 left from a 30-gram sample after 1 hour. So I always read them once and then I go back and look at it. Okay, this bismuth 214, don't get hung up on that. That's just the name of the substance. Okay, that has nothing to do with putting anything into the equation. Okay, so it says this is the T part that's kind of tricky. Okay, so this T part right here, it says the half-life is approximately 20 minutes. So that means it cuts in half every 20 minutes. It says find the amount left from a 30-gram sample after 1 hour. So I'm going to plug in my 30 for that P. Then I'm going to put in 0.5 because that doesn't change. And so now my T, okay, is 20 minutes, okay, and I want to know after 1 hour. So 1 hour equals 60 minutes. So if you just reason this out and think about it, what's happening is if it cuts in half every 20 minutes, how many times did it cut in half in 60 minutes? Well, 20, 40, 60. It cut in half 3 times. So our T is going to be 3, okay? And how we get that is we take our time, T, which is 60, and we divide it by the half-life time, so to speak, which is 20, and that's how we get 3. So that's how we get that T right there, is we take the time right here and we divide it by the half-life time. A lot of times you can just think about it. I mean, a lot of these are going to be pretty obvious. We're making them fairly simple for you, okay? All right, let's try one more. And then you can feel free to go to your homework, or if you feel comfortable now, you can. All right, so now we have a next question. Says strontium 90 has a half-life of 29 years. Okay, that's just the compound. We don't need to enter any of that into our equation. About how much strontium 90 will be left from a 100 milligram sample after 290 years, round to the nearest 1,000. Okay, so we know the half-life is 29 years. Okay, we start with a 100 milligram sample. It's cutting in half, and it's cutting in half every 29 years. So after 290 years, how many times will it cut in half? And some of you can already see this, that it's going to be 10. But again, we take our time, which is 290, divide it by the half-life time, which is 29, and that gives us 10. So now we raise that to the 10th power, calculate that out, pause the video, see if you can get this. But your answer should be 100 and should be 0.098 grams is left. I don't think I actually ever calculated the first one, so go ahead and we can do that one as well. The final amount in the first one is actually 3.75. Kind of missed that, sorry. All right, so hopefully this is making sense. Half-life is tricky a little bit, but just remember that T part right here. Just remember that and how you get it. That's the trickiest part. So go ahead, find a homework, go ahead and give it a try, make sure you're checking your work. If you want to stay on the video right now, I am going to work through 2 from your homework. So you could grab your homework out of Schoology, pull it up, and watch and listen as we go through 2 together. All right, so let's try a few from our homework. First one says, if 12,000, this is number 5 we're working on. If $12,000 is invested at a rate of 2.6% compounded quarterly, find the value after 15 years. And we're going to make sure we give you these equations all the time, even on the quiz or test. So, but again, this is the original amount. Okay, that's what's getting invested. That goes in for P. So we have 12,000 times 1 plus our rate. Okay, our rate is 2.6%. Again, we don't put in 2.6 there. We have to change that into the decimal into or percent into a decimal by taking 2.6 divided by 100, which is moving the decimal point 2 places, 0.026. And it's compounded quarterly right here. So quarterly means 4 times per year. So that's what we put in there. Then we raise that to the NT power. So the number of times compounded is 4 times the time, which in this case was 15 years. Okay, again, make sure you're including these extra parentheses here or changing these. This has to go in parentheses right here, or you could just put a 60 in there. And you need to put the 0.026 divided by 4 in parentheses. So you have double parentheses there, or you can put in the decimal equivalent, which is 0.0065 instead. So this would be that. Okay, so now go ahead, pause the video, see if you can enter this correctly on your calculator. And if you have done this correctly, you should get a value of $17,701.42. So I'm not writing these on the line, but this would be where your answer would go, and your equation would actually go in here. A lot of times you're going to see the equation on the answer key. What they're going to do is they're going to leave this time right here in your equation. They're just going to put that in as a big T in your equation so that you can keep varying it. Okay, I'm not going to get too concerned about that, but basically the way to write this equation is 12,000 times 1 plus 0.026 divided by 4, and then we're just going to put a T there. Because that way, if we wanted to change, hey, what's the value after 10 years, after 20 years, after 13 and a half years, we can just change the T. And that's why we kind of put these equations sort of more in general at times when we enter them, when we write them down, I should say. All right, let's try one more from your homework, and then it's your turn. All right, next question. Bismuth 214 has a half-life of approximately 20 seconds. Find the amount of bismuth 214 left from a 30-gram sample after 120 seconds. Okay, so again, don't get hung up on these words. That's just the name of the compound. Okay, don't put that 214 anywhere in your equation. So we know it's a half-life problem right here. It has a half-life of approximately 20 seconds. It cuts in half every 20 seconds. So find the amount after 120 seconds from 30 grams. So we have a 30 gram initial starting size, and we have 0.5. It's cutting in half, 1 minus our rate of 0.5, and then we're going to raise it to the T power. The T is taking 120 seconds and dividing it by 20. Okay, so that's what we're going to do. If we were going to just write the equation, we would leave T kind of open so we could change it. So we could put a T there. But I'm going to go ahead and simplify this now. And 120 divided by 20 is a 6. So that's equal to 6. So now we're going to take 30 times 0.5 and raise it to the 6th power. Pause the video, see if you get this correct. And your answer should be 0.469 grams. All right, good luck. You can message me or email me any questions that you might have. Have a great day.